Hey Algebra 1, well today lesson 3.5, solving systems of linear equations by elimination. So this is the second method that you can use algebra to solve, to solve systems instead of graphing them like we've done in the past. Yesterday we did substitution. Today we're going to learn another way to get to rewrite these equations so that you have a single variable rather than an x and a y. So the way to get there, they summarize the steps up here, but I prefer to dive into a problem first. So what we're going to do is we're still going to want to write these side by side. So I'm going to write the 3x plus 2y equals 4 right there and just kind of get rid of that. But then what's important with solving using elimination is that everything needs to line up right before you do the next step. So see how it's x, then y, then the equal sign? X, then y, then the equal sign. These line up perfectly. As soon as that you realize they line up perfectly, write one equation under the other. Now, the reason this is called elimination is you're going to try to get one of the variables to eliminate, to go away. And how you do that is by doing something kind of revolutionary. We're going to add these equations together. And if you don't believe me that you can add equations together, do you agree that 3 equals 3? I bet you do. Let's add to that 2 equals 2 because you agreed I bet you agree that, whoops, it helps if I write it right. I bet you agree that 2 is equal to 2. Well, if you add those together, you'll get 5 is equal to 5. It's still true. And so we're going to use that idea here. What you want to do is before you add them together, you want to see if either the x or the y will eliminate. Well, to eliminate, they're going to have to be exact opposites. And we actually have that here. We have a negative 2y and a positive 2y, and those will eliminate. And I like to do a satisfying slash through them. They're going to eliminate. They're gone. Technically, it's 0, but 0 plus whatever we get over here is just going to be whatever we get over here. So we have 6x is equal to 0. Now I do write the 0 there because there's nothing else over there, so I got to have something on the other side of the equation. And then to get x by itself, we'll divide by 6, and we'll get x is equal to 0. Take that 0, and then we'll do like we did yesterday. We'll substitute it into one of our other equations, and then figure out what y is. And I can do the rest in my head if you believe that. This is going to be 0. 0 plus 2y is 2y. Divide by 2, we get y is equal to 2. So just like yesterday, we're going to write our answer as an ordered pair. Whoops. 0, 2. In class, I encourage you, check your answers. Practice doing that arithmetic in your head to check your answers. 0 here, 2 here, that's negative 4 equals negative 4. 0 here, 2 here, that's 4 equals 4. It checks out. Everything works. Okay, so again, write them side by side first. Make sure they're lined up. If they're not lined up, you're going to have to rearrange them, move some things around, but these are lined up pretty nice. Yep, everything's lined up, so I'm going to write one under the other. And we're going to see, we want either the x's or the y's to eliminate, and right now, nothing will eliminate. If I added these together, I'd get negative 20x and a negative 9y, and it wouldn't help my cause at all. I would just generate another equation. So I want to get these to eliminate. Well, what I'm going to do is I'm going to take this bottom equation, and I'm going to multiply it by a negative 1 to everything, to both sides. So when I do that, I'm going to get a 10x minus 3y equals a -1. Now I'm going to go ahead and rewrite the one that was above. I'm just going to write it underneath so we still have everything. Well, when I do that, I got my x's to be opposites, to be exact opposites. And therefore, they will eliminate. And y is equal to -3, substituted into the other equation. And x is equal to -1, y is equal to -3. We've got our answers. And again, we could check our answers by substituting them in. Try to do a little bit of mental math. I think it's kind of satisfying to do that. See if they work out. And I'm just noticing here that they do. Yeah, they totally work out. All right. So notice, class, we had to do... we had to multiply one of our equations. We had to manipulate one of our equations to get them to be opposites. And this is kind of a downside of elimination, is sometimes you have to do a lot of manipulation to get them to eliminate. With substitution, you got to get one of the variables by itself. So it's kind of a toss-up on which is better. You know, I think some problems are better suited for elimination and some problems are better suited for substitution. You know, just depends if you can easily get a variable by itself. All right, let's flip it over, see what else we got going on here. So I'd like to mix this up a little bit. Instead of using that top equation, let's instead write -5y equals 2x plus 9. Let's write that instead. Okay, so class, ignoring the original problem, these don't match up. They don't line up. And for us to do elimination, everything's got to line up perfectly. So this is good. This is in standard form. That's typically what we prefer for doing this. X, then y, then the equal sign. But this is y equal sign, then x, then another number. So what we need to do is we need to move this 2x out front. So let's subtract that 2x out to the front. So we'll have -2x minus 5y equals 9. Now they match up, and we'll write one underneath the other. Okay, I really wanted to do a problem where we had to do that first, because that's pretty common actually to have to do that. Now, will either the x or the y eliminate right now? No, not at all. And we can't get away with just multiplying by a negative, or another way to phrase that is subtracting. Yeah, they're not exact opposites. We do have opposites, so that's good. So we've got options here. We can either eliminate the x's or eliminate the y's, and it doesn't matter which. Often I'll eliminate the one that requires smaller numbers to multiply by. What I mean by that is to get the x's to match, to be exact opposites, I'm going to multiply this top equation by a 2 and this bottom equation by a 3 to make them -6 and 6. If I had decided to get rid of the y's, I would have multiplied, the top one by 5, the bottom one by 11, and that would have gotten them both to be 55, positive and negative, and those would have been exact opposites. But I've decided to get rid of the x's here, so I'm going to distribute a 2 to everything, a 3 to everything, and now, now the x's will eliminate. We'll be left with a 7y equals, and then that would be a 35. And then y is equal to 5. We just had just enough room there. Now take that 5, substitute it in. -2x minus 5 times 5. Clean it up a little bit. And then I do something sketchy here? Oh, I'm silly. I added the 5s together instead of multiplying them. That's more like it. Add that over, we'll get 34 divided by, so we'll get negative 14. I'm sorry. Yeah, take my time here. My mind is elsewhere. Oh, how about negative 17? Yeah, negative 17.5. And again, we can check our answers pretty quickly to find out what's going on, even though 17 is a pretty big number. I might use a calculator to help me check. Okay, so class, what I would encourage you to do, yesterday we did a word problem that involved a money equation, and then an equation that they just told us the relationship. They told us an equation, right? Today we've got 2 money equations, and I got a feeling that you guys might be successful trying to write these equations on your own. So I'd encourage you to pause the video and try to write these 2 equations. Okay, hopefully you were able to write 2 equations. I'm gonna go ahead and jump in. It's interesting, they tell us that a business buys 7 large delivery vans and 5 small delivery vans. And class, it's often when you're solving a problem in real life, you're gonna have information that's not needed. It's just not applicable. And it turns out that's nice to know, but it's not applicable to this situation. It's not gonna help us to solve, because what are we trying to find? Trying to find the cost of each type of van. That doesn't help us, but they tell us location A receives 5 large vans and 2 small vans for a total cost of that. So that's good information there. Location B, 2 large vans and 3 small vans for that. That's good information. We're trying to find the cost of each type of van. So I'm gonna make X be the large delivery vans and Y be the small delivery vans. And I think I'm ready to write 2 equations. 5x plus 2y equals 235,000. And for our second equation, 2 large vans, 2 times the cost of a large van plus 3 times the cost of a small van will equal $160,000. And yeah, they line up nice. So I'm gonna write one underneath the other. And now class, if I was to add these up right away, they would not eliminate. I can either get rid of the X's or the Y's. I'm gonna decide to get rid of the Y's this time. I'm gonna multiply the top equation by 3, the bottom equation by 2. That'll make them both 6. But here's the thing, I don't wanna make them both 6. I wanna make them opposites. So I'm gonna multiply the top one by -3. And then 3 times 235, that's a big number. Beep boop bop boop beep. My calculator told me that I get -705,000. On the bottom equation, 4x plus 6y equals, I can do this, 320,000 without the calculator. And now, we can eliminate the y's and we get -11x equals beep boop bop boop beep, -385,000. Divide by -11 and we will get the cost of a large van. Large van costs $35,000. Substitute this back into our other equation and we'll find the cost of a small van. Subtract the 70,000 over, you'll get 90,000. Divide by 3, you'll get $30,000. So this was the cost of a small van. This was the cost of a large van. Thanks for watching.